Good evening, Titans. This is Mr. Sturts. We are now on lesson 6.5, solving exponential equations. So get your student journal out or your notebook, wherever you best take notes, and we'll get rolling. All right, our vocab word, exponential equations. Okay, get this written down in your notes. This is an equation in which variable expressions occur as exponents. Okay, so we're going to have variables in our exponents now, set them equal to each other, and we're going to solve. All right, our core concept is two powers with the same positive base. Okay, if we remember what a base is, if we think of our powers, 2 to the 4th power, okay, 2 is our base, 4 is our exponent. We're looking for like bases. All right, they're the same, they're equal if their exponents are equal. Okay, for example, the example they give us here, 2x is equal to 2 to the 5th. We have to first check if we have like bases. Okay, we see a 2 here and a 2 here, so we're good. We're going to ignore those and set our exponents equal to each other. X equals 5, and we have our answer. Okay, obviously if we plugged in 5 for x in this left problem here, we're going to get the same thing. They're equal to each other. All right, couple examples. Part A here. First thing we always check is, do we have like bases? And it looks like we do. They're both 3. So let's ignore our bases. Set our exponents equal to each other. X plus 1 equals 5. If we subtract 1, think back to earlier chapters. We're just solving simple equations. Solve for x. Subtract 1, x equals 4. And we've got our answer. All right, let's look at part B. Again, do we have like bases? Yes, we do, but we're missing an exponent. Okay, we just see the 6. Well, we remember from earlier sections that if we don't see an exponent, we assume it's a 1. Now, like bases, ignore them. Set our exponents equal to each other. 1 equals 2x minus 3. And again, solve for x. We're doing opposite operation here, so we're adding 3. Add 3, so we get 4 equals 2x. We're multiplying, so do the opposite, which is division. So x equals 2. All right, in part C. Again, like bases. They were nice to us. They gave us like bases on all 3 of these. So cancel them out. Set our exponents equal to each other. 3x equals 2x plus 3. Now, let's move our x's first. Okay, this was a positive 2x, so we're going to subtract it on both sides. So 3x minus 2x, we're left with a single x. X equals 3. All right, now way to check your answer. We see x equals 4, so really what we can do is take that 4, plug it back in for x. 4 plus 1 is 5, so we have 5 is 5, and our exponents are the same. Okay, we get 3 to the 5th power equals 3 to the 5th power. All right, moving on, a little tougher now. Okay, notice they did not give us like bases. Okay, and this takes a little more work. Okay, but we can do it. So we don't see an exponent. We know it's to the first. We got to get these to be like bases. Okay, we can't really change the 5, but let's change the right side. We can change this 125. We can rewrite it so it has a base of 5. Okay, so our goal is to get a base of 5. So the left side says 5x. But the right side, we need to write it so it has a base of 5. We got to think of 5 to what power gives us 125. Okay, remember power is exponents. That means we multiply it by itself that many times. So if we have 5 to the 2nd power, which is 5 times 5, that only gives us 25. But if we think of 5 multiplied together 3 times, that's going to give us our 125. Okay, that's going to give us that number. That's what we want. So we're going to rewrite it as 5 to the 3rd. Now we have like bases. We can set our exponents equal, ignore our bases. X equals 3, and we're done. All right, so the main goal is to rewrite our bases so they're equal. We can't do anything until they're equal. So we look at part B, we see a 4 and a 2. Okay, they're not equal to each other. We can't really rewrite the 2, but we can rewrite the 4 to get it to a base of 2. So we got to ask ourselves, what power can we take 2 to get to 4? All right, so let's rewrite the 4. Let's see, we know we want a base of 2, and we ask ourselves, what power of 2 gives us 4? Well, we know 2 times 2 is 4. So let's put that, make sure we keep that in parentheses, and don't lose your x out there. Okay, that x is very important. Now, 2x minus 3. Okay, sloppy x there, that's an x. Now, think of power of a power. When we have right here, these two, we multiply together. So if we rewrite it, we have 2 raised to now the 2x power equals 2 to the x minus 3 power. Now we're there. Like bases, set our exponents equal and solve. So we have 2x, again we're ignoring our bases, they're alike, equals x minus 3. Subtract our x over, we get a single x equals negative 3. Again, we can't do anything until our bases are the same. Alright, part C, we're going to have to rewrite both sides this time. Alright, because we can't rewrite 27 as 9 to some power, because 9 squared is too big. So we need to rewrite both of them. Let's rewrite the 9 first. Let's write it as a power of 3. Alright, so let's have 3 be our base. And 3 to what power is 9? Well, we know 3 times 3 is 9, so 3 squared is 9. And keep our exponent out there, x plus 2. Keep it out there. Equals, now we have a base of 3 over here. We need to rewrite 27 with a base of 3. Well, 3 times 3 is 9. If we do another 3, 3 times 3 times 3 is actually 27. So 3 to the third power, again, keep your parentheses. Okay, keep your parentheses there. Let me get rid of some of this stuff. Keep your parentheses, and then also don't lose your exponents. Okay, don't lose your exponents. So what we need out there, we need our x still. Whoa, what do we get here? Oh, there we go. Okay, we need our x still. Now, power of a power, multiply. So what we have here is, we have right here 2 times x plus 2. So let's rewrite that. 2 times x plus 2 equals 3x. Now, remember when we're multiplying, we have to distribute. So 2x plus 4, 2 times 2 is 4, equals 3x. Okay. Now, solve for x. Okay, we did the tough part. Now we're just solving a simple equation. Subtract 2x, subtract 2x. So what we're going to get is, in the end, x is equal to 4. Alright, and we got our answer there. Alright, so if we plug those in and check them, they should check out. Okay, x equals 4. Alright, and let's see. We need to solve part A and B here. Okay, again, A. Now, this is tough again. We don't have like bases. We got to rewrite it. Okay, if we think of 1/2, if we think back to section 1 and think with our negative exponents. Okay, if we have 1/2, we can rewrite this and have a negative exponent with a base of 2. Okay, let's move that exponent. If we move it up, 2 to the negative first power is equal to 1/2. Okay, now we have 2 to the negative first, keep our x. Now the right side, we have 4. We need to rewrite it with a like base. Okay, we know a like base can be 2. So if we rewrite it as 2 squared equals 4. Okay, these are equal. We're working with just part A right now. Now, power of a power, multiply exponents. So negative 1 times x, we have 2 to the negative x power equals 2 squared. We have like bases. Okay, that's what we had to get to. Now we can ignore them. Set our exponents equal to each other. Negative x equals 2. Remember, that's the same as a negative 1 out there. Divide by negative 1, divide by negative 1. X equals negative 2. Alright, so again, we cannot do anything until we have like bases. Okay, there's a bunch of tricks. We'll talk about more of them in class, okay, but we got to rewrite those bases to be the same. Alright, let's get rid of this. Let's do part B, and then we'll be done. Okay, part B. Again, another tough one. We have a fraction. Now, this is kind of tough to see. Let's rewrite this. This is actually 4 to the x plus 1 equals 1 over 64. Okay, kind of tough to see there. We're rewriting that part A. Now, we need a base of 4. Okay, in the right side, we have 1 over 64. Nowhere near. Okay, nowhere near the right base. So let's work with that right side. We can rewrite 64 as a power of 4. Okay, so we got to ask ourselves, how could we rewrite it? 1's going to stay up top. 4 to what power is 64? If we use our little chart, we're going to see it's 4 to the third power. 4 times 4, 16 times 4 is 64. Okay, so we're kind of getting there. Now we have at least a 4, but we need it in the numerator. So think back to section 1 again. Let's rewrite that. Now we need it in the numerator, so we got to move it to the top, which means that changes the sign of our exponent. So we have 4 to the x plus 1 still on the left side. We don't have to do anything with that. If we rewrite the right side, move it to the top, that makes it a negative 3. Okay, again, whenever we switch sides, we change the sign of our exponent. Finally, like bases, cross them out. . Set our exponents equal to each other. X plus 1 equals negative 3. subtract 1, so x equals a -4. Alright, and we got to our answer. Alright, so the toughest part is rewriting them so we have like bases. Now that you're done with your notes, okay, go to your student journal. Please try these. Go to page 191. Try these 4 problems. It won't take you too long. If you don't know how, that's okay. At least give them a shot. We will talk about them when we get to class tomorrow. Have a great night.